Hello, class. This is Mr. Hart, and in this podcast, I want to go over the last section of storms and also finish up the weather chapter. And the first thing we want to talk about is cyclones. And the cyclones are very similar to tornadoes, like we talked about last time. Okay, so if we look at a cyclone from an aerial view, it also has a low pressure area, just like a tornado does, and it also gets a lot of rotation from the high pressure winds and things like that. And so tornadoes and cyclones look very similar in structure, but the main difference is a cyclone happens over water, whereas a tornado happens over land. Okay, so tornadoes don't have as much moisture as cyclones do, because cyclones, when they happen over water, they bring a lot of the moisture and the water with them. So the damage that cyclones do aren't associated so much with the wind speed, it's associated more with the water and the water damage that comes with it. Okay. They usually raise the tides and things like that, which can cause flooding and other things as well. So cyclones can be very dangerous because of all the water they bring with them. Okay. But you probably have never heard too frequently the word cyclone on the Weather Channel or somewhere like that because we don't usually call them cyclones. If a cyclone happens in the Western Hemisphere, we call it a hurricane. You've probably heard of a hurricane before. Okay, so that's the word we most commonly use. And we also use typhoon if it happens in the Eastern Hemisphere. Okay, so you probably heard of things like a Hurricane Katrina or a typhoon that struck India or something like that. Okay, these are the more common words that we use. Okay, so let's look at hurricanes or cyclones. Okay, so again, if you look at what the hurricane looks like, you can see it's very similar to a tornado in its structure, but it also brings again this large amount of moisture from the water below. Okay. Um, Here's an aerial view. This is an actual satellite image taken from Katrina, or a computer generated data image from a satellite. And you can see kind of it has that eye of the storm and this large circling around. And you can also tell this thing is pretty dang big if you look at that. This is kind of one part of Mexico, and this is Florida over here. So this is spreading across the entire Gulf of Mexico, which is really quite fascinating and incredible that it's that large. Okay, but if you remember Hurricane Katrina, you may have been pretty young, but I remember watching on the news and seeing Hurricane Katrina strike, and it was just incredible amounts of damage. Okay, the main place getting the most damage being New Orleans in Louisiana. Okay, and again, you can see that not so much the wind, but just all the water damage that occurred as this happened. And New Orleans was especially vulnerable because New Orleans is actually set beneath sea level. Okay, they actually have barriers near the ocean, and the city is actually below sea level, which is really bad because when that tide came in and the water surged in, it just did incredible amounts of damage to the city. Okay, so hurricanes not the best place to um, not the best place to be at when a hurricane strikes. Okay, um, but again, incredible amounts of damage, not so much from the wind, but from the water. Okay, so we want to be able to understand hurricanes and understand that again they are like tornadoes and they come from these pressure differences. Okay, and in class we watched a video on hurricanes by Modern Marvels, which is very good at explaining what they are. Okay, but the last storm we're going to cover is blizzards. Okay, and if you've ever driven in a blizzard, you know it's not very fun. Okay, it's not just your average day snowstorm. And so there's a couple of things that happen in order for something to qualify as a blizzard. Okay. So if something is called a blizzard and not just a snowstorm or not just snow, it has to have temperatures below -7 degrees Celsius or 20 degrees Fahrenheit. Okay. Its winds have to be greater than 56 kilometers per hour or 35 miles per hour. And the snow has to be so heavy that visibility is a fourth of a mile or less. Okay. And that's just for something to be considered a blizzard. Okay. There's other conditions for what we call a severe blizzard, which is something you do not want to be driving in. Almost no visibility, very high wind speeds, and very cold. Okay. And so blizzards are, again, main reason they are dangerous is because of the visibility factor for drivers and things like that. If you're inside your house and a blizzard happens, the main thing is you just can't go outside for a while. but they can be very dangerous for drivers and because of all the snow and the low visibility. Okay, and we can see um, when blizzard strikes, they bring large amounts of snow, and you can see them across entire states and things like that. So very, very large storms. Okay, but they just happen again from cloud buildup and just if the conditions are right, that's when a blizzard will happen. Okay. All right, so that is it for storms. The last thing we want to talk about really isn't a storm, but it's just a weather phenomenon that we want to be aware of. Okay, that is becoming more and more important over the past couple of years, and that is what we call acid rain. Okay, so acid rain is what it sounds like. It's rain that has high amounts of acid in it, or is very acidic, as it's called. And here's a picture of a statue, and you can see these little dents in the statue all over the place. And this is not a very old statue, or it might be a very old statue, but these dents are not caused by natural erosion. These are caused by acidity in the rain in this area. So as the rain falls and it stays in the statue, the acid eats away at the rock in the monuments. Okay, so this is starting to become more and more of an issue. Okay, because acid rains can destroy monuments. It can wipe out forests and wipe out ecosystems if we're not careful. And so a lot of concern has been what is causing acid rain. There's been a lot of concern of why is this happening and are we affecting it. And one of the main theories is that a lot of it's coming from, again, our production of gases that are going into the atmosphere from power plants and things like that. So as these gases rise into the atmosphere, they pollute the atmosphere, and the particulates come down with the water and the precipitation. And so the water is not just regular water, it is very acidic as well, which is why we are often told not to drink rainwater. Okay. And so a lot of people are wondering if we should prevent some of these gases from being put in the atmosphere. It's very related to things like global warming and the ozone. Okay. Are we changing the atmosphere, and is this acid rain becoming a problem? Okay. And so I just want you to be aware of it and why it's happening and just some of the effects of acid rain. Okay. One problem is it damages plants, that makes them more susceptible to pests and things like that because a lot of their natural um, protections are being broken down from the acid. Lakes can become more acidic, which kills the organisms inside of them, like the fish and the algae and things like that. Crops become damaged. Buildings and monuments erode, like we saw, and forests and their ecosystems can be destroyed. Okay, so we just want to be aware of some of these effects, and in the future there may be things that come up about acid rain, and there may be things we need to vote on or things like that. Of what do we do about it? Do we try and prevent it? How can we make it less of an issue? Things like that. So I just wanted to make you aware of what acid rain is as it comes up in the future. Okay. But that is the end of the chapter on weather, and hopefully it was an interesting and fun chapter. A lot of cool things that we covered, especially the storms section. But let me know if you have any questions, and thank you for watching.